Hello everyone, let's see more on functions and their graphs. When we're defining how functions change, we can identify intervals over which the function is changing in specific ways. We say that a function is increasing on an interval if the function values increase as the input values increase within that interval. And similarly, a function is decreasing on an interval if the function values decrease as the input values increase over that interval. And also we say that a function is constant on an interval if the function values constant as the input values increase within that interval. And here we are going to define the intervals of this function is increasing, decreasing or constant. And if we take this function, we can see from negative infinity to negative 1, this function is increasing. So the interval of increasing is negative infinity to negative 1. And also here we can see from negative 1 to positive 1, this function is decreasing. So the interval of decreasing is negative 1 to positive 1. And after positive 1, we can see this function is again an increasing function. So again we can define the interval of increasing, that is 1 to positive infinity. Here we are going to define the relative maximum and relative minimum if there exists an open interval containing a value a such that f of a is greater than f of x for all x is not equal to a in that interval. In this case, a function value f of a is called a relative maximum. And also if there exists an open interval containing a value b such that f of b is less than f of x for all x is not equal to b in that open interval, in this case a function value f of b is called relative minimum. And if we take this example, we can see on this interval here we have a relative maximum at x equal negative 1. And also if we take this interval, here we can see here we have a relative minimum when x is equal to 1. Here we are going to define an even function. The function f is an even function if f of negative x is equal to f of x for all x in the domain of f. That means if we change the value of x into negative x, then after changing that value, if we have the same function f of x, in this case we call this function is an even function. And also if we take an even function, that is also symmetric with respect to the y-axis. And this is an example for even functions. And after changing x into negative x, now the function is equal to negative f of x for all x in the domain of f. In this case we call the function f is an odd function. And also if we take an odd function, that is always symmetric with respect to the origin. And if we take the function fx equal x cubed, that is an example for odd functions. Here we are going to determine whether this function is an odd function or an even function. To identify whether this one is an even or an odd function, first of all, we need to change the value of x into negative x. After changing value of x into negative x, here we will have negative x to the fifth plus 1. Now that's equal to negative x to the fifth plus 1. We can see this value of h of negative x is not equal to h of x. So here we can say that this function is not an even function. Since this one is not an even function, then after that we need to check whether this one is an odd function. To do that, we do the same thing here. We change the value of x into negative x. Then after changing this value into negative x, here we will have negative x to the fifth plus 1. If this one is an odd function, we know that the value of h of negative x must be equal to negative h of x. To check that, we need to check the value of negative h of x, and after simplifying this one, we will have negative h of x is equal to negative x to the fifth minus 1. And if we compare these two functions, we can see h of negative x is not equal to negative h of x. So here we can say that the function is not odd. And our conclusion is the function h of x is neither odd nor even. And here we are going to define piecewise functions. If we define one function by using two or more equations, in that case we call that function as a piecewise function. Here we have an example for piecewise function. Our function is c of t. Now we can see here we have two equations. Now the value of t is in between 0 and 60. The value of c of t is equal to 20, and the value of t is greater than 60. Now the c of t is equal to this equation. And here first we need to find the value of c of 40, and in this case the value of t is equal to 40. So we can see now the value of t is in between 0 and 60, because now t is equal to 40, and we know that when value of t is in between 0 and 60, c of t is equal to 20. So the c of 40 should be 20. Now we need to calculate the c of 80, and now here we have t greater than 60. Now in this case we need to take the second equation. Now c of t is equal to 20 plus 0.4 times t minus 60. To calculate c of 80, we take the second equation and we change this value of t to 80. Then after that we can simplify this one, and we will get c of 80 is equal to 28. Here we are going to graph the piecewise function f of x. It is given that if x is less than or equal to negative 1, f of x is equal to 3, and also if x is greater than 1, the value of f of x is equal to x minus 2. Before graph this function, first of all we have to make two tables for f of x when x is less than or equal to negative 1, and also if x is greater than 1. Here we can select the values of x, -1, -2, -3, and also here we select x, -1, 0, +1. For these x values, we can calculate the value of f of x for the first equation. In this case, the f of x is equal to 3. And also for the second case, f of x is equal to x minus 2. When x is equal to these values, now we can calculate the values of f of x. And we have these points after calculating the f of x. After that, we do the same thing. We plot these points on the plane and we connect them. Here we are going to define the difference quotient of function. If we take the expression f of x plus h minus f of x over h, that is called the difference quotient of the function f. In this case, always the value of h is not equal to 0. Here it's given that f of x is equal to -2x squared plus x plus 5. Here we are going to calculate the difference quotient of this function. To calculate the difference quotient of this function, first of all we need to find the value of f of x plus h. To find this value, first we have to change the value of x into x plus h. Then after changing x into x plus h, here we will have -2 times x plus h squared plus x plus h plus 5. Then after that we can simplify x plus h squared. That becomes x squared plus 2xh plus h squared plus x plus h plus 5. After simplifying this one, we will have f of x plus h is equal to this expression. And after taking the value of f of x plus h, we can calculate the difference quotient of that function, that is f of x plus h minus f of x over h. So now here we need to plug the value of f of x here. This is the value of f of x plus h over h. Then after that we can simplify this one furthermore, and here we will have the different quotient of f of x is equal to -4x minus 2h plus 1. Thank you.